Hi, this is a help video to try and help you understand how to calculate the maximum height of an object that's fired at an angle other than horizontal. So in this example, I have a projectile that is being fired at a velocity of 28 meters per second with an angle of 40 degrees. So the projectile reaches its maximum height right here, which is where the vertical velocity, the velocity in y, reaches 0. So I'm going to call that T1. Now I break down the two velocities. Vx is equal to V naught times the cosine of theta, and I don't really need that for maximum height because really I'm only looking at the y direction. This problem is the same as a problem where I had just thrown this up and I wanted to know what the maximum height was, like in free fall. The only difference is that Vy I have to calculate first. So Vy is equal to V naught times the sine of theta. Once you've got a value for Vy, it's all free fall. It's just like throwing an object up in the air and asking how high will it go. So in this case, the distance that it's going to go normally would be equal to the velocity, initial velocity times time, minus 1/2 gt squared. I distributed the minus sign in the g to the front there. But in this case, we don't know what the time is, so we need to compute it. Well, the time right here is where the velocity is equal to 0. And we have that old equation, final velocity equals initial velocity plus AT. We can rearrange that for when VF equals 0, and we end up with this equation right here, which is T1, I called it, is equal to V naught times sine theta over G. So now we have the time at which the vertical velocity is 0. So I now have an equation for my height that is a function of time, and I have my time. So really all I've got to do is calculate the time and substitute it back into this equation, and I've got an answer for my maximum height. If you're more bold, you can substitute in the actual formulas right here for time, in place of time, and in place of time squared, which is what I did here. So I have my V naught sine theta right here, times T right here, minus 1/2 G, so that's G over 2, times time squared, so I have this quantity squared. Once I did that, I went on and wrote them out, separated out. I've got V naught twice, and I have sine theta twice. Here I have V naught squared and sine theta squared. I also have G squared in the denominator, but I have it once in the numerator, so one of these will cancel out, and I end up with G on the bottom. So now I have this function minus half of that function. So basically I end up with half left over. So my maximum height is V naught squared times sine theta squared divided by 2G. So let's plug that into the calculator and see what I get in this condition. So I have my D max is equal to 28 meters per second, and that's quantity squared, times the sine of 40 degrees, and that's squared, divided by 2G, so that's 2 times 10 meters per second squared. Plug that into my calculator. 28 squared times sine 40 close parentheses squared divided by 20. And I get for dx 16 point, well, it says 1965, so I'm going to go 16.2 meters. And there you have it. Here I have corrected the equation to show that the distance we were calculating there at the end was the distance y max. I moved over to the left side where I normally keep my x calculations and started writing x.